Hello. So we are back with a new problem from empirical and molecular formula. As you can see in this problem, it is given that a sample with a molar mass, so molar mass is given as 34.00 gram per mole, is found to consist of 0.44 gram of hydrogen and 6.92 gram of oxygen. So we have to find its molecular formula. Now these types of numerical actually we do in three steps. So at the very first, what you have to do, we have to find out the number of mole present in the given amount. So there, in case of hydrogen, it is given by 0.44 gram. So what is the number of mole of hydrogen in 0.44 gram? So given amount by the atomic mass of hydrogen, that is 1. So for your information, I can tell you the mole is given by W by M. Mole or number of mole N is given by W by M. Here W is the amount given or taken and M is the atomic or molar masses. So therefore hydrogen, what will be the number of mole? So amount taken is 0.44 divided by the atomic mass, that is 1. So ultimately it is coming 0.44 only, right? Now in case of oxygen, you see the amount taken how much? 6.92. And what is the atomic mass of oxygen? 16. So if you carry out this division, it will come 0.433. So now we know the number of mole of hydrogen, that is 0.44, and number of moles of oxygen, that is 0.433. In the step 2, what we will do? The step 2, we will have a ratio of their mole. We'll have a ratio of their mole. So hydrogen and oxygen will have the ratio like that: 0.44, 0.433. Now in between these two, what is the smaller value? 0.433. So in the step 3, we'll have the simple ratio. We'll have simple ratio. So what will be the simple ratio of them? So simple ratio of hydrogen and oxygen will be 0.44 divided by 0.433. Again 0.433 divided by 0.433. Remember, when we are talking about the empirical formula, we have told you that empirical formulas are the simplest whole number ratio. So there you see 0.44 by 0.433, it is nearly approximately equals to 1, and the latter one 0.433 by 0.433, it is also equals to 1. So ultimately hydrogen and oxygen, their ratio is becoming 1:1. So the empirical formula of the given compound will be HO or OH, right? So empirical formula, we are getting HO. Now in the question, the molar mass is supplied. So we know the formula N equals to molar mass by empirical formula mass. Now there, what will be the empirical formula mass? Just find it out. So for hydrogen it is 1, and for oxygen it is 16, that is 17 is the empirical formula mass. So there we can find out the N, right? So there the value of molar mass is given in the question paper. That was 34. If you can remember, it was 34. And the empirical formula mass, it is coming how much? 17. So what is the value of N? It is 2 only. Now we know the empirical formula. We know the value of N. So we can find out the value of molecular formula, right? So we know molecular formula will be so there we have empirical formula, that is hydrogen and oxygen in the ratio of 1 and 1. So whenever we are trying to find out molecular formula from empirical, we multiply it with the N value, that is 2. So what it will be? It will become H2 and O2. So H2O2, that will be the molecular formula for the compound that is given in the question paper. I think it is clear to you. So if you have any kind of query regarding this question, you can raise your query in the comment box. So thank you for watching the video.